Shielding gas and backing purging. Deck 3, gas tungsten arc welding stainless. So the whole thing, gas tungsten arc welding, pretty important. The shielding. Why does the shielding matter? Well, it protects our weld from oxygen, number one. Oxygen and nitrogen do bad things to liquid weld metal, pretty much kills any mechanical properties. The weld metal gets brittle, loses ductility. We can get cracking, oxides, just a laundry list of bad things can happen. If we don't shield, we also are going to contaminate our non-consumable tungsten electrode. That's bad because we're not going to be able to weld for very long. And when we talk about why shielding matters, well, it prevents that from oxidizing. And it also prevents our stainless steel from oxidizing. So this is super critical for stainless steel. If we don't have shielding, we're in a world of hurt. It's going to be bad. So what happens without protection? Oxidation. On the inner root, we get a thing called sugaring. This is a rough, crusty, nasty looking root. And what it does is it means we've lost corrosion resistance. Whatever fluid is on the inside of that pipe is going to chew through that oxidized, sugared root and start wrecking the metal. So that's a bad thing. We do not want that to happen. So you can see there we've got the blue arrow in the picture pointing to the sugared root compared with the non-sugared root on the left. And then that far left is what a sugared root looks like after we've kind of cleaned it up a little bit. Still pretty rough and nasty, craggy. So torch shielding, the top side. So we're going to have an argon shield, and that's shielding the arc. It's covering our weld puddle, and it's going to stay over the weld. And a lot of times we'll have a pre-flow when we're TIG welding, and we'll also have a post-weld gas flow. So this is going to just let the gas flow over the weld metal and the solidified weld metal once we quit sending electricity through the tungsten. So you just hold your torch there for 8 or 10 seconds or whatever the time frame is to let that metal, your stainless steel weld metal, and that heat affected zone cool down enough so that it's not going to be under attack from oxygen and nitrogen in the atmosphere. So we've got a thing called back purging, and this is inside protection. There's a lot of different ways we can do this, and a lot of different gases that we can use. So there's a whole laundry list of gases that you can use to back purge different materials. So what we're doing is we're filling the pipe that we're welding with a backing gas, usually an argon-based material, and there might be other things in there. But this is going to shield the root side of the weld, not the torch side of the weld. It's going to shield that inside of the weld, which is still hot, and if it's liquid metal, it's going to come in contact with oxygen and nitrogen if we don't have that backing gas, that back purge, and it's going to sugar, and we're going to get that oxidation. So we put a back purge in there, and we'll fill the pipe with an argon or some kind of argon mixture. And this is how we're going to do it for stainless steel. Carbon steel, we can get away with not doing this sometimes, depending on our welding process and what's going on. So what is backing gas? It's the shielding gas used on the underside of the weld. And like I said before, it protects it from atmospheric contamination. We use it generally for gas tungsten arc welding, or if we put the root in with gas metal arc welding or plasma arc welding. Plasma arc welding and gas tungsten arc welding are pretty similar, but it protects that backside from atmospheric contamination. So one of the things when you qualify welders, and this is just kind of a little side thing, is if you qualify a welder to weld with no backing gas, they can weld with backing gas. But if you qualify the welder with backing gas, they can't weld without a backing gas. But anyways, in this picture here, you can see the difference. I guess, I tried to put together graphics that show the backing gas. We've got argon on that left side. And then over on that right side, we've got nitrogen and oxygen and whatever other constituencies are floating around in that gas in that pipe there with no backing gas. So good root versus bad root. Good root, going to be smooth, shiny, good. Bad is going to be dark, crusty. You can see the picture here. That's going to be bad. The color is going to tell you the story on whether what that weld bead is ready for. Do we need to cut it out? Is it just burnt and nasty looking? Or is it nice and shiny in there and got a good contour? Gives us an idea of what we can do with it, what our end disposition is going to be for that thing. So a simple purge setup, there's different ways to do this, and depending on what you've got going. So you're going to seal the ends with tape, plugs, dams, whatever. And you're going to feed argon into the pipe. And then you're going to measure how much, you're going to use an oxygen monitor to figure out how much oxygen is in there. Because a lot of these things have a specification that says, well, your oxygen in that on the inside of that pipe has got to be a certain number or you don't weld. So, we usually leave a small vent hole for the oxygen to escape from. And this is a good idea. You can have these big purge dams. Sometimes they put these in there with rice paper. So you put rice paper purge dams in there because you can't get the purge dam out. So they'll put rice paper ones in there before they fit the pipe up, and then they'll run the purge gas in there. But anyways, the rice paper, when they run a water or hydro it, the rice paper just dissolves. Life's good. We move on. So with a purge, we want to go low and a steady flow. We're not just blasting this in there because you're going to get turbulence. You're going to suck more oxygen and nitrogen in there. We just want to go low and slow. And we want to allow time for the air to purge through there. We want time for the oxygen and nitrogen to be able to find its way out. And once we start welding, we're going to maintain that purge. The flow is going to be maintained while we are welding. So common mistakes. We forgot the purge. No purge. We don't need a purge. Well, that can get ugly and we can have to cut welds out. Maybe there's a leak in the setup somewhere. Some of your purge dams, maybe, I don't know, hoses, whatever. We can have leaks. Bad things happen. We start welding too soon. We put the purge in there, but then we just started welding. Too much flow. We put way too much gas in there. We're going to get a lot of turbulence, and it's going to flow and just look nasty. We're going to get contamination. That if we have too much flow, it's going to pull oxygen and nitrogen in there, and it's going to contaminate our weld puddle. Well, the back side of it, that root side of the weld puddle, we're going to get sugaring. So the reality of this, purging takes time. Time prevents rework, and rework costs more money. And I know I'm not saying anything that we all don't know on these, but that's where we're at. We need to remember this. Bottom line, no purge, we're going to get a bad root with stainless steel. Bad root, failed service. So we need to do it right the first time.